now we're going to use trig to find unknown sides, unknown angles of right triangles without having enough information to use the Pythagorean theorem, without needing the Pythagorean theorem, until we are told to solve a whole triangle. Then we're going to have to use a little bit of everything, okay? So what you do with this, you look at the triangle, you look at what you're given. Here I'm given this angle. This is the side I'm trying to find, x, and this is the side they give me, 25. You want to look at the relationship between the two sides they give you with the angle you're given. So x is opposite 64, and 25 is the hypotenuse, right? So what trig ratio uses opposite and hypotenuse? That would be sine, right? So we're going to say the sine of 64 is x over 25. So you're going to take the sine of 64 degrees, use your calculator. That is 0.8988 if we take it out to 4 decimal places. And that is x over 25. Then we're going to use our equation solving skills. We're going to multiply both sides by 25. And this says to round to the nearest tenth, so we're going to get x is about 22.5. So we found that side measure using the sine ratio, okay? So I want you to look at number 2 and number 3. I want you to figure out which ratio to find or to use. Solve for x, turn the video back on and check it, and then we'll talk about number 4. All right, for number 2, I got that x was about 12.9, and in number 3, I got x was about 32.3. Number 2, I used the tangent ratio because I had the opposite leg and the adjacent leg to 47. Number 3, I used the cosine ratio because I had the adjacent leg to 18 and the hypotenuse, okay? Notice I don't clear out my calculator until the very end, so even though I wrote 0.8988, that actually filled my calculator screen, and all I did was times 25. You'll save yourself some time, and you'll have a more accurate answer if you'll just leave that ratio in there and then multiply by the number and don't have to clear out and put more digits in, okay? So let's look at number 4. It's just a little different, nothing big, but let's see what's going on here. We've got this angle. We have the opposite leg, that's 9. We have the adjacent leg is x. So what is opposite and adjacent? What trig ratio are we going to use? We're going to use tangent, right? So we're going to say the tangent of 35 is opposite, that's 9, over adjacent. Here, what's different about this is the variables in the denominator. So let's find the tangent of 35. We get 0.7002, and that equals 9 over x, okay? A couple of things to do here, a couple of ways to get there and get an approximate answer that is correct. We can now multiply both sides by x to get x out of the denominator, and we get 0.7002x equals 9. Now we have to divide both sides by the 0.7002, okay? So 9 divided by 0.7002, and I get x is approximately 12.9, okay? So that's a little different. When x is in the denominator, you have to get x out of the denominator before you can finish solving it. Now, what if they give us the sides and we have to find the angles? Well, this is going to be what we did when we talked about calculator use. We're going to have to use our inverse function. This is where you're going to use your second key or your shift key because we're trying to find the angle this time, not the sides. All right, so number 5, we're trying to find theta. We're given this 8 and this 14. What are their relationship to theta? Well, 8 is the opposite side, opposite leg, and 14 is the adjacent leg. So opposite and adjacent, we're going to use tangent. So we're going to say the tangent of theta is 8 over 14. So we get the tangent of theta. We do 8 divided by 14 in our calculator. And we get this decimal, 0.5714. Now I'm just going to leave that in my calculator as it is. I'm going to hit my second key, then my tangent key, and I get theta is approximately 29.7 degrees. Okay, so you use that. Look at number 6. Find the trig ratio you're supposed to use. Remember, you'll have to use your inverse function. Use your second key on your calculator to find theta. I used cosine because 38 is the adjacent leg to theta, 40 is the hypotenuse. So I used cosine. This was a nice little pretty decimal, didn't have to worry about it a whole lot. Use my inverse cosine, my second cosine on my calculator, and I got my theta was about 18.2 degrees. Here are 2 more for you to try. I'm going to let you do these. You pause the video, try both of these on your own, then turn the video back on, check your work, correct it if you need to. Number 7, I used sine because I had the opposite leg in the hypotenuse. I got theta was approximately 50.6 degrees. Number 8, I used cosine because 11 is the adjacent leg, 48 is the hypotenuse. Now notice, again, I write a rounded number here, but I actually leave that in my calculator. The longer I wait to round, the more accurate my answer will be. Okay, these next type of problems are the fun ones. They're going to give you 2 pieces of information, either a side and an angle or 2 sides, and they're going to tell you to find everything else about that triangle, the rest of the sides and the rest of the angles. So if I have a right triangle, I know that usually my little leg is A, my longer leg is B, hypotenuse is C, right? The angle across from side A is a capital A. The angle across from, or opposite, side B is capital B, and the right angle is always capital C. Okay, if you remember that, that'll help you keep everything in sort of straight. So we need to find side A, side B, and side C, and we need to find angle A and angle B. We already know angle C is 90 degrees. It's a right triangle. So 1 part is done for us. We got to find 5 parts. They gave me little a is 15.2. I'm going to come over here and write that in. And they gave me angle B is 38.3 degrees. So they were nice. They gave me 2 pieces of information. So first thing we want to do, we want to look and say, okay, what else can we find? Well, we can find angle A pretty easy, right? What do we know about the angles of a triangle? The angles of a triangle add up to 180. So we're going to say 90 plus 38.3. And we're going to get 128.3. We're going to subtract that from 180. And we get that the other angle is 51.7 degrees. So this angle is 51.7. So finding that third angle was not a big deal since we already had one, right? Now we got to find the other 2 sides. We have some options. There are many ways to do this. I may choose to do one way, you may do it another way, but we should get the same answer in the end, okay? So I'm going to use this angle B here. Side B is opposite angle B, and they gave me the 15.2. So opposite over adjacent, I'm going to use the tangent ratio. I'm going to say that the tangent of 38.3 is little b over 15.2. And then I'm going to use my calculator. And the tangent there is 0.7896. And I get b over 15.2. I'm going to multiply both sides by 15.2. And I get b is approximately 12.0. But lots of decimals there. I'm going to say b is approximately 12. So the only thing I'm missing is the hypotenuse. You have some options here. You can use the Pythagorean theorem. A squared plus b squared equals c squared. You can use the angle you were given. You could say what? You could use I like using something they already gave me because I know that's accurate. I'm not real thrilled about using the 12 because I had to round it, but it's not the end of the world if I use it. So if I want to use something that I haven't rounded, I can use the angle they gave me, the side they gave me. This would be adjacent. C is the hypotenuse. I could use cosine there, right? So I could say the cosine of 38.3 is 15.2 over C. So this is one where the variable's in the denominator. I'm going to find the cosine. I get 0.7848 equals 15.2 over C. I'm going to multiply both sides by C. And then I'm going to take 15.2 and divide by 0.7848. And I get C is about 19.4. So I get 19.4 there. You could use Pythagorean theorem if you use, let's see what happens here, 12 squared plus 15.2 squared, and I'm going to take the square root. You get 19.36, which is 19.4. You should get something very close regardless of which way you use. Okay, this one they give us two sides. What I'd like you to do is sketch the triangle, see if you can find the remaining side and the two angles that you need. I'm going to do it, and you can turn the video back on and check your work, or you can look through the video if you get stuck. But see if you can do this one on your own. Remember that you can use all your trig functions, and you have the Pythagorean theorem you can use. Your answer should be close to mine. There may be a little bit of rounding, but there shouldn't be too big a difference. So pause the video, try this one on your own, see what you can do with it, then turn the video back on to check. Okay, so here's what I did. Yours, you may have approached it a little differently, but you should still have very, very similar answers. Since they gave me two sides, I decided to use Pythagorean theorem to find the third side. So a squared plus b squared equals c squared. I got the hypotenuse was about 20.4. Then, I don't like using an answer I've already gotten. For one, if I got this answer wrong, then if I use it in something, I'm going to get the next thing wrong. Also, this is rounded. This is not exactly exact. They gave me these two numbers, so if I can use these two numbers, I'm going to. So that's why I chose to do tangent for both of the others. For A, opposite is 13.1, adjacent is 15.6. When I rounded, I got A was about 40 degrees. Now, using the angles of a triangle, I could right then subtract and find the other one. But because of rounding, I thought I'm going to go ahead and use a trig function. I used the tangent of B, opposite over adjacent, using those two they gave me, not anything I'd already used. I don't like using something I've already found. So I used the two they gave me, and guess what? It all worked out. 40, 50, 90, that gives me 180. Everything worked out. I used Pythagorean theorem. I used tangent twice. Again, you may have done it different. Your answer should still be very, very close to mine.